Our exponents are Marisa Pineda, Melanie Mancia, Maricela Amador, and Manuel Diaz.
Hi, my name is Marisa, and today I'm gonna talk you about the carboxylic acids. And you're wondering what are the carboxylic acids? The carboxylic acids are any of a class of organic compounds in which a carbon atom is bonded to an oxygen atom by a double bond and to a hydroxyl group by a single bond. A fourth bond links to the carbon atom to a hydrogen atom or to some univalent combining group. The carboxyl group is so named because of carbonyl group and hydroxyl group. The chief chemical characteristic of the carboxylic acids is their acidity. They are generally more acidic than the other organic compounds containing hydroxyl groups, but are generally weaker than the familiar mineral acids. This type of organic compounds can be obtained by different routes. Some carboxylic acids, such as citric acid, lactic acid, or fumaric acid, are produced by fermentation. Most of these type of carboxylic acids are applied in the food industry.
Hi, my name is Manuel, and I'm gonna talk about the functions of carboxylic acid. The first function is carboxylic acid make up a series of fatty acids which are excellent for human health. The second one is the omega-6 and omega-3 are essential fatty acids which are not produced by the body. The third function is they help in maintaining the cell membrane and control nutrient use along with metabolism. Omega-3 and omega-6 are known as essential fatty acids because the body cannot produce them on its own, so it must obtain them from food. Some foods of omega-6 are the bird meat, avocado, and whole grains. Some foods of omega-3 are nuts, shellfish, sardines, tuna, or salmon. Another functions are manufacturing of soaps need higher fatty acids. Soaps are generally sodium or potassium salts of higher fatty acids such as stearic acid. Food industry uses many organic acids for the production of soft drinks, food products, etc. For example, acetic acid is used in making vinegar. Sodium salts of organic acid find application in preservatives. The last functions. In pharmaceutical industry, organic acids are used in many drugs such as paracetamol is to alleviate the pain, salbutamol for asthma, aspirina for almost everything, phenacetin for fever reducing drug in both human and veterinary medicine for many years. Acetic acids are often used as a coagulant in the manufacturing of rubber. Organic acids find huge applications in making dye stuff, perfumes, and rayon. They are used for organic acids are used for oil and gas well stimulation treatments.
Carboxylic acid UPAC rules. As with the aldehyde, the carboxylic group must be located at the end of a carbon chain. In the UPAC system of nomenclature, the carboxylic carbon is defined in the number 1. and other substances are located as their name is accord. The characteristic UPAC suffix for the carboxyl group is the oic acid. We must take care to not confuse them with the systematic nomenclature in the common system. These two nomenclatures are illustrated down below. The amino acid theorem, for example, do not have any systematic origin and must simply be memorized. In other cases, common names make use of the Greek letter notation. Carbon atoms near the carboxylic group. Some examples of both nomenclatures are these ones. Simple carboxylic acids have the general formula of HO2C, CH2N, CO2H, where N equals 0 to 5. The common names are oxalic, malonic, succinic, glutaric, adipic, and pimelic acids. The common names such as this one can be troublesome to others to be remembered. Some mnemonic acid can take a catchy phrase. The phrase for this group is, "Oh my such good apple pie." Carboxylic acids are widespread in nations. They often combine to other functional groups. Simple alkyl carboxylic acids, composed of 4 to 10 carbon atoms, are liquids or low melting solids having very unpleasant odors. The fatty acids are important components of the biomolecules known as lipids, especially fats and oils, as this table shows. These long-chain carboxylic acids are usually referred to by their own common names, which in most cases reflect their sources. A mnemonic phrase for the C10 to C20 naturally fatty acids, compric, lauric, mithric, pelminic, esteric, or arachidic, is Curry, Larry, and Moe perform silly antics. The following formulas are examples of other naturally occurring carboxylic acids. Other functional group combinations with the carbonyl group can be prepared from the carboxylic acids and are usually treated related derivatives. 5 common classes of these carboxylic acid derivatives are listed in this table. The neutralists do not have a carbonyl group. They are included because they all have the same oxidation state. Functional groups of these kinds are found in many kinds of natural products. Some examples are shown below. The functional groups are colored. Most of the functions are amides or esters, cantarine being rare of an example of a natural anhydride. Cyclic esters are called lactones, and cyclic amides are referred to as lams. Penalizing G has 2 amide functions, one of which is B-lactam. The Greek letters locating the nitrogen related to the carbonyl group of the imine.
Reactions of carboxylic acids. Number 1. Acid plus metal goes to salt plus hydrogen. For example, ethanoic acid plus sodium to sodium ethanoate and hydrogen. Number 2. Acid and base goes to salt plus water. For example, ethanoic acid and sodium hydroxide become sodium ethanoate and water. And 3. Acid plus carbonate go to salt plus carbon dioxide plus water. Carboxylic acids also give another important reaction called esterification. Here they react with alcohols to give an ester plus water. An example is ethanoic acid and ethanol to ethylene. O8 and water. This is a reversible reaction, which can be seen from the directions of the tool arrows shown in this reaction. A few drops of concentrated sulfuric acid are added. This sulfuric acid acts as both a catalyst and to remove the water formed, thereby displacing the equilibrium.